Good morning, sir. I'm Charita from ECE. I'm pursuing a BTech first year in Srinivasa Ramanujan Institute of Technology. Today I'm here to explain about whole circle bearings and uses of contour maps. Before entering into the topic, I want to give a brief explanation on whole circle bearings. A whole circle bearing is a system where the direction of a line is measured in clockwise from north, ranging to 360 0 degrees to 360 degrees. The WCB of a line always falls between 0 degrees and 360 degrees. The reference meridian is typically the magnetic north, but it also can be true north or a grid north. I'm going to give an example. A line with a WCB of 0 degrees is pointing directly north. A line with WCB of 180 degrees is pointing directly south. So, importance in BTech programs. Understanding WCB is a crucial for civil engineering students as it is a fundamental concept surveying and mapping which are essential tools for designing and constructing infrastructure projects. So, introduction to whole circle bearings. Whole circle bearings or a method of expressing direction in degrees. They range from 0 degrees to 360 degrees starting from north and moving clockwise. This system provides a clear and ambiguous way to communicate directions in navigation and surveying. Understanding whole circle bearings. WCB is used to describe angles in the horizontal plane relative to true north. Each degree represents a specific position, making it easy to pinpoint locations. The system simplifies calculations when determining the direction of lines or points. Applications of whole circle bearings. Whole circle bearings are widely used in surveying for mapping and land assessment. They provide essential information for navigation in aviation or maritime contexts. Engineering often utilize WCB in construction projects to ensure accurate directional alignment. Now, introduction to contour maps. Contour maps, also known as topographic maps, use lines or contour lines to represent elevation and terrain features, showing hills, valleys, and slopes on a 2D map. So, what is meant by contour maps? Contour maps are the lines that connect points of equal elevation, allowing users to visualize the topography of an area. They are commonly used to represent the three-dimensional landscape of the Earth with the two-dimensional space of a map. Now, what is meant by a contour line? Contour lines are the curves that connect the points of the same altitude. The space between contour lines indicates the steepness or gentleness of the slope. Close contour lines indicate a steep slope, while the widely spaced lines indicate a flatter terrain. Now, how to interpret a contour maps? Hills and valleys, slope, steepness, index contours. Navigation. Now, now I'm going to tell about uses of contour maps. Navigation and planning, engineering and construction, geological studies. Examples of contour maps are topographic maps and isotherms. Now, introduction to contour maps. Contour maps are graphically representations of the terrain's elevation using contour lines. These lines connect points of equal elevation, illustrating the shape and steepness of the slab. They are essential tools in fields like geography, civil engineering, and environmental science. Understanding the contour lines. Contour lines on a map helps visualize a three-dimensional landscape on a two-dimensional surface. The spacing between contour lines indicates the slope of the terrain. Closer lines signifies the steeper slopes. Different colors or line styles may be used on a contour maps to enhance readability and clarity. Uses of contour maps. Contour maps are crucial for land use planning and development to assess areas for construction. They aid in hydrology studies by showing watershed boundaries and drainage patterns. Contour maps are also useful for outdoor activities like hiking, providing elevation information for trails. Combining whole circle bearings and contour maps. Integrating WCB with contour maps enhances navigation and spatial analysis. Surveyors use whole circle bearings to orient themselves accurately on contour maps during fieldwork. This combination allows for better planning and execution of construction and environmental projects. Advantages of using whole circle bearings. The clarity of WCP helps eliminate confusion in directional measurements. It allows for easy conversion between different coordinate systems in surveying. WCP improves efficiency in communication among professionals in navigation and surveying. Advantages of contour maps. Contour maps provides a comprehensive view of the terrain, aiding in decision-making processes. They facilitate the identification of natural features like hills, valleys, and water bodies. The visual representation helps non-experts understand complex topographic information easily. Conclusion. Whole circle bearings and contour maps are essential tools in surveying and navigation. Their applications span various fields, improving accuracy and understanding of spatial relationships. Mastery of these concepts is crucial for professionals in geography, engineering, and environmental sciences. Thank you.